All right, you guys, so let's go ahead and get started here with lesson 6.6. This is going to be square root equations. We are working with square root equations here. So in this case, guys, we want to go ahead and identify any extraneous solutions whenever we're working with square roots. So once we find solutions with square roots, we still have to substitute them back into the equation to check for extraneous solutions there. So just a few things, guys. Whenever we're working with square roots, any value that goes inside of the square root does have to be a positive in this case, or a 0. It can't be negatives in this case just because we'll get involved with having imaginary numbers. So we're not focused on that today. So once again, no negative numbers inside the square root. Steps in this case, guys, in order for us to solve a square root is we want to go ahead and first isolate any radical, or isolate the radical. Basically, move everything that's on the outside of the radical to the other side. From there, once you do that, you want to go ahead and square both sides. In this case, square both sides to get rid of the radical. And then we work on solving for the variable, which means moving anything that's left with the variable to the other side. So last step would be to check for any extraneous solutions here. So in this case, guys, just something basic with square roots here. Starting off with the square root of -3, the square root of 64 minus 3 equals 5. I do want to go ahead and just solve for this. What's the square root of 64 in this case? Square root of 64 is going to give us 8. 8 minus 3 is going to be a 5. And this is just checking if the statements here are true, because when we check for extraneous solutions here, we do need to check that both sides are equal to the same number in order for determine if something is a solution. If it doesn't equal the same number on both sides, then it's not considered a solution, it's considered an extraneous solution. So let's go ahead and get started here with this one. And once again, we want to go ahead and solve for x, and have 1 plus the square root of 2x plus 3 equal to a 6. Now, in this case, guys, once again, we want to go ahead and focus on, first on basically moving everything that's on the outside of the radical. Now, I am going to be doing two things. First thing, I want to go ahead and just draw a line through my equal sign, just so I could know what two sides. So this is one side of the equation, this is another. Now, in this case, guys, I want to go ahead and focus once again on everything that is outside of the radical. So whatever is inside of the radical, that actually goes at the end. So what we find on the outside of the radical is actually this 1. So in order for us to get rid of that 1, we actually have to do the opposite. That 1 is actually being added there. So I'm actually going to go ahead and subtract 1 to both sides. All right, and then we have the square root of a 2x plus 3 equals 5. Now, there's nothing else left on the outside of the radical here that's on the same side. So now we want to go ahead and focus on canceling out the radical. In order for us to cancel out the radical, I do have to do the opposite of square rooting, which is squaring. So what I do to one side, I do to the other. Now, this here eliminates the square and the square root, and we're left with the 2x plus 3 equal to square root of, or 5 squared in this case is going to give us 25. Now, in this case, guys, now we want to go ahead and focus on isolating the variable. So I'm actually going to go ahead and move the 3 first. In order for us to move the 3 here, I do have to do the opposite. So I'm going to go ahead and subtract 3 to both sides. And that gives us a 2x equal to 22. Next step in this case is that I actually want to go ahead and get rid of the 2. The opposite here of multiplying a 2 is actually dividing. So I'm going to go ahead and divide both sides by a 2. And x in this case is going to be equal to 11. Now, this here 11 is a possible solution. I still need to check in the equation to see if this works. So in order for us to do a check here, I will be substituting. So our check here, we have to substitute the x value. So wherever I see an x in this case in my original equation, I will be substituting it for 11. So we have 1 plus the square root of 2 times 11 plus 3 equals 6. So in this case, 1 plus the square root of 2 times 11 is 22, plus 3 equal to a 6. Now 1 plus the square root of what's 22 plus 3 in this case is going to give us 25. Once again, it's still equal to 6. The square root of 25 in this case is going to be 5. And 1 plus 5 is 6. So this here works, which means that x equals to 11 is a solution. So this here is a solution. It works for us. All right. So let's go ahead and move on to the next one here. Let's go ahead and move on to the next one. And here's the next one. Well, this is actually a practice problem, so go ahead and do this one on your own. And I'll go ahead and move on to example 3. And in this case, guys, let's go ahead and focus once again. Starting off, since we are solving for x here, I do want to go ahead and first just create a line in between or through my equal sign, just so I could determine where both of my sides are. Now, notice in this case, guys, we do have a variable on each side. Now, before I can move any variables to one side or the other, I do have to get rid of my square root. Now, I do say get rid of the square root because there's nothing on the outside here or nothing in the front of the square root. So because there's nothing in the front or in the outside of the square root, I am going to be getting rid of it. So in order for us to get rid of a square root, I want to go ahead and square both sides. And in this case, this actually cancels out the squared and the square root. And I'm left with x plus 10. And on the left-hand side, x plus 4, all of it squared is actually the same thing as saying x plus 4 times x plus 4. All right. Now, in this case, guys, on the left-hand side, I do have to multiply this out. I do want to go ahead and multiply that out. Now, in order for us to multiply that out, there's two ways you could do it. You could actually do the area model, or you could use distributive property. I'm going to go ahead and show distributive property here. So multiplying x with the x and then x with the 4. So x times x in this case, guys, is going to be x squared. And x times 4 is going to give us a 4x. All right. Let me just bring this down. Then moving on to the next one, 4 times an x is going to give us a 4x. And then a 4 times a 4 is going to be a 16. So now let's go ahead and combine those. And in this case, I have an x squared plus an 8x plus 16. And all of that is going to be equal to x plus 10. All right, so that's what we have. Once again, I did distributive property here. Did distributive property there. So that's how we got that answer. If you don't like distributive property, you could do the error model. So in this case, guys, once we do that, we have an x squared plus an 8x plus 16 equal to x plus 10. Now, in this case, guys, I do want to go ahead and emphasize on something. What is our highest exponent here? Our highest exponent here is a 2. When your highest exponent in this case is a 2, that means that you could actually factor the equation here by using the diamond method. Now, in order for you to factor, you actually have to make your equation equal to a 0. So, in this case, in order for us to make the equation equal to 0, I'm actually going to be moving all of this to the other side. So I'm actually going to be subtracting an x and subtracting a 10. So I'm going to go ahead and do 2 steps in one. Subtract an x here and subtract the 10 there. All right. So that cancels out what's on the right-hand side. And we have x squared plus a 7x plus 6 equal to a 0. Now, in this case, I could actually focus on factoring this with the diamond method. So let's go ahead and first identify A, B, and C. So A in this case, guys, is a 1, B is 7, C is 6. Now, based on that, we're going to go ahead and build the diamond here. And I have A times C on top, and I have B on the bottom. A times C in this case, guys, is 6, B is a 7. So two numbers that multiply to a 6 and add up to a 7 in this case would actually be 6 and 1. Since my leading coefficient here is a 1, I could actually move on to writing my binomial. So let's go ahead and write them on this side. So I have x plus 6 times x plus 1, and all of that is going to be equal to a 0. Now, we are solving for x in this case, so in order for us to solve for x here, I do have to make each of the expressions that have a variable equal to 0. So I have x plus 6 is equal to 0, and x plus 10, or plus 1, I'm sorry, equal to 0. Now, let's go ahead and solve for x there. I'm going to go ahead and subtract 6 to both sides. Subtract 6 here. And I have x equals a negative 6. And then subtract 1. And x in this case equals a negative 1. All right. Now, once again, those won't be our final answers because we still need to check them. So before I box them in, we need to check them. So in order for us to check, once again, we have to substitute it back to our original equation. So this equation that I'm highlighting in green, we have to substitute it back. So let's go ahead and do a check here. A check. So starting off with the value of x equals negative 6. So wherever I see an x in my original equation here in green, I'll substitute it with the negative 6. So it's negative 6 plus 4 equals the square root of negative 6 plus 10. In this case, guys, negative 6 plus 4 is going to be a negative 2. And then the square root of negative 6 plus 10 is actually 4. Now, square root of 4 in this case, guys, is going to be a 2. Question for you here is negative 2 equal to 2? Answer in this case is false. So this here would be considered an extraneous solution. Extraneous solution. All right, so that one doesn't work for us. That one's not going to work for us. So x equals negative 6 is not going to be a solution for us. It doesn't work for us here. So it's not a solution. Now let's go ahead and try with x equals negative 1. All right, so wherever I see an x in my original equation, I'll go ahead and substitute it for a negative 1. All right, so negative 1 plus 4 is 3. And then the square root of negative 1 plus 10 is 9. Square root of 9 in this case, guys, is 3. And 3 in this case does equal 3. So this here is considered a solution. So our only solution in this case, guys, is x equals negative 1. All right. And if you guys are absent, this is actually the practice problem I'll be checking, and this will be going into your grade. So make sure you complete the notes and this problem